students, this lab is called the Milk of Magnesia Equilibrium Lab. The point of it is to, first of all, explore acids and bases, and particularly a type of molecule called an indicator, which changes color based on the pH of the solution. Secondly, we connect to an everyday substance, the substance that maybe your parents give you if you have an upset stomach, called milk of magnesia. And then thirdly, we're going to create several equilibria based as evidence for, we're going to get evidence for it based on the color change of the indicator molecule, and then we're going to disrupt it. So we establish a new equilibrium, disrupt it, establish a new equilibrium, and disrupt it. So equipment, we've got household vinegar. I'm going to pour the vinegar into a smaller beaker so that it's easier to pour from. This is the stuff that you'd buy at a grocery store. You can cook with it, you can clean with it. Vinegar has many uses. Its scientific name is acetic acid. Milk of magnesia, which you can also get at a grocery store. It's a stomach or laxative, making your stomach feel much better if it's upset. And then thirdly, we have a substance called the universal indicator. The universal indicator is, believe it or not, is itself an acid molecule that will sometimes dissociate and sometimes not based on the pH. This particular one has many different colors, which if you look at the procedure part of the lab, you can see a color scheme, and we'll be using this to roughly identify the pH as we go forward. The procedure says, fill the small beaker, the 150 milliliter size beaker, with acetic acid. Keep this at your station because we'll need lots of that as we go along. For the larger beaker, the 600 milliliter size, we're going to add 400 milliliters of tap water. So I'm just going to walk over to the sink here. It does not need to be deionized water. Just regular old tap water will do. Got our tap water. And then there's a cool piece of equipment that's going to help us as we go along here. This device is called a stir plate, and it has a magnet on the inside that rotates as I turn the motor on. There's a knob here that I can adjust the rate at which the magnets inside rotate. This is a little magnet itself called a stir bar, sometimes called a pill because it looks a lot like a little pill. Well, I'm going to drop that into the beaker of tap water, set it on the stir plate, and so that I don't need to spend all of my muscle energy stirring the solution, I'm going to let the stir plate do it for me. And as you can see, the stir bar inside the solution is stirring on its own, making a little whirlpool, so that whatever I dump in here is going to be stirring without my needing to do extra work for it. Okay, now we're going to take a graduated cylinder, and we're going to measure 20 milliliters of milk of magnesia. So we'll pour into the grad cylinder. To the 20 milliliter line. We're going to add this to the large beaker of water. Kind of a thick whitish fluid. I'm going to rinse this with some tap water, and it's okay to add more volume as I'm doing the rinsing here. So I'm just going to take a little bit of tap water and rinse, and I'm going to dump that in here as well. Okay, now I'm going to rinse again with tap water. This time I'll dump the excess out so that we've got all of the milky white stuff out of the grad cylinder, and we're ready to proceed. So now I've got my clean graduated cylinder. Next, we're going to take the indicator solution, And the procedure says add 5 to 10 milliliters. So that's about 3 droppers full. So I'm just going to squirt liberally into here. And as you can see, we've got kind of a bluish purplish color. Now, if you look at the color chart in the procedure, that would mean its pH is quite high right now. I'd even give it an estimated pH of about 10. If you follow along in the data table, you'll be able to, describe the color of the solution that you see, and then tell us, based on that color and the chart that you see in the procedure, roughly, like within 1 or 2 of the pH scale that you see here. Okay, so now we've got milk of magnesia in a solution with an indicator. That's a base. Okay, pH is high. We're going to slowly, in 5 milliliter increments, add acetic acid, or vinegar, which is an acid. That's going to neutralize the base, which actually gets us into another really cool lab that we'll be doing shortly. So I'm going to use my grad cylinder, and I'll pour about 5 milliliters of acetic acid into the solution. Now watch the color change. So we've got like a yellowish, maybe orangish color. Again, refer to your color scale in the directions. Oh, we went back blue. So it was orangish, yellowish, and then when we went back to bluish, greenish. We're going to record whatever the final color is. So let the color in the beaker distribute. So if there was a brief amount of yellow, you kind of know what's happening. The pH is going down, but if it returned to bluish, purplish, then record bluish, purplish. And you might not see, for every 5 milliliter increment of the acid, you might not see a color change, but eventually you'll see definite and persistent color changes. So we'll go for another 5 milliliter increment. Again, watch the color change. Greenish, bluish, a lot of cool colors. Returning to a blue, maybe not quite as dark as it once was, but it's still bluish. The next 5 milliliter increment. So now the total amount of acetic acid added is 15 after this one. Ready? So every step that we pour is another 5 milliliters of the acid. So we went yellowish. Let's see if we return. Yep, back to blue. So another 5 milliliters brings the solution to a total of 20 milliliters of acetic acid added. Note the color change. Okay, another 5 milliliters. Now we're going to be, once I dump this next grad cylinder in, we'll be at 25 milliliters of acetic acid added. And now we're getting a slow return to blue. This tells you something. Remember, we're establishing an equilibrium and then disrupting it. Establishing a new equilibrium and then disrupting it. Once I pour this grad cylinder in, we'll have 30 milliliters of acid added. Still back to a bluish color. Once I add this grad cylinder, we'll be at 35. Ooh, are we getting back? Yep, barely. Boy, it took a while. Students, it took a long time for it to get back to blue there. We're starting to overwhelm the indicator. All right, once I pour this grad cylinder, we'll be at 35 milliliters of acetic acid. Oh boy. Will it go back to green? Yep, it's back to green. Will it go back to blue? Yep, it'll go back to blue. But it doesn't go back to purple. After this pour, we'll be at 40 milliliters of acid added. Will it go back? Will it go back? Back to green. Almost. There we go. There's green. Back to blue. Yep. Once I pour this in, we'll be at 45 milliliters of acid added. Ooh, seems to be at yellow. Is it going to go back to green? So if you take a quick look at the color scale here, it goes yellow would be a pH of about 6, green would be at about 7, darker green 8. Okay, I think it's starting to go at least lightish green. Maybe not. Okay, maybe we're like we're doing what's called the titration, students. We'll have the next lab will have a chance to measure this much more precisely. But what we're doing is we're like right at the balancing point between acid and base. So yeah, I'd say we're at light green, kind of a lightish green. Now, if I pour this next graduated cylinder of acid in, we'll have added 50 milliliters of acetic acid. Ooh, you see the red? There's a bit of red now, returning to a yellow color. By the way, we don't have to go all the way through the data table. We're going to stop once we get a persistent red color. Okay, back to yellow at this point. Once I add this graduated cylinder, we'll be at 55 milliliters of acid added. Red for a little bit. Then going back to, well, slowly returning to yellow. Once I add this, I don't know, I'd call this like reddish yellow. Once I add this graduated cylinder, we'll have added 60 milliliters of acid. And now we're starting to get almost red. We're very close to stopping here. Once I add this one, we'll be at 65. And now you can see kind of a persistent red. Let's do one more just for good measure, students. I want to be sure that we can see all the color changes possible. And after I add this graduated cylinder, we will have added 70 milliliters of acetic acid. And now we have a persistent red color. Again, if you want to estimate the pH, look at the color chart in the procedure and write down your best estimate. This can be a rough guess. And that's it, students. As far as the lab report for this one, it's, isn't it cool that substances change color? We started with a base, we added acid to it, and with the help of an indicator molecule, we saw color changes.